All right, these are going to be called binary, decimal, octal, and hex conversions, okay? Um, the numbers that we have are 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when we go to another digit, where I should say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go back to 0. So this scrolls every 10 digits from 0 to 9. And then if it add one more, it puts one in the next place. We talk about binary. Binary is a base 2 number system. It is what computers use. So a number in binary might look something like this, 1011. Usually they put a little subscript there to show you it's a base 2. All right, because if you and I or anybody normal would be looking at this, they would see it as like 1011, perhaps. The digits in binary are only ones and zeros. These guys are called bits. All right, 1 is a bit, 0 is a bit. All right, easy. So I'm going to ask you on a quiz, what's a bit? And there it is. A byte is going to be 8 bits in a row. So here's a byte. Here's an example of a byte. 1, 0, 1, 1, 1, 3, 4, 5, 6, 7, 8. That's a byte of memory. Now there's conversions, and we can convert our base 10 to binary and vice versa. So take a look. If I give you like an example here of, let's say, 28 in base 10, and I want to know what it is in binary. Well, what we're going to do is we're going to use something called the Marashio table. The Marashio table has been around for years. And all it is a table that starts with 1 and doubles every time. So here's the table. 1, 2, 4, 8, 16. I would go 32, 64, etc. You never want to go larger than what that number is. That's important. You never want to go larger. All right, you can go up to it. Like if this was 16, I would go to 16. And what you do is the first one will get a 1 all the time. And I'll start taking 28 and subtracting each number I put a 1 above. So it's 28 minus 16 is 12. So I ask myself, and we go through this the whole time, can I subtract 8 from 12 without going negative? The answer is yes. So I put a 1 above, and I subtract 8 from it. Can I subtract 4 from 4 without going negative? The answer is yes. So I'll put a 1, subtract 4. I'm left with a remainder 0. When you have no more, the rest are zeros. So this number in binary is 11100. As easy as that. Let's do another example. And this is going decimal to binary. So give me a number. Let's go like 114 in base 10, and let's see how it is, what it is in binary. Another example. So what I'm going to do is I'm going to make my Marashio table. And the Marashio table goes 1, 2, 4, 8, 16, 32, 64. The next one would be 128, which would be over 114. So I put 114 here on the side, and I say, can I subtract 64 from it? Of course, without going negative, and I get an answer of 50. So, can I subtract 32 from that without going negative? Sure. And I get 18. Can I subtract 16 from 18 without going negative? Sure. I subtract 16. I'm left with 2. So then I ask, subtract 8 from 2 without going negative? The answer is no. So I can't. I can't do it with 4, and the only thing left is the 2. So I'm going to go ahead and subtract that 2. We're left with 0. So my binary number is 1110010. As easy as that. I want you to try, couple. You try 7, take 7 and put it into binary. And now you take, let's go something crazy, like 444. And let's put that into binary. And if you can get those two, I think you're set. Now, I'm going to go the other way around. I'm going to go from binary now to decimal. All right, this binary to decimal, we'll give you a binary number like 10110. In binary 1, I don't know what it is in decimal. That Marashio table is going to come in huge. All right? All we do is set up the number, 10110, and we put a little Marashio table underneath. 1, 2, 4, 8, 16. And we add up all the ones that have a 1 above it. 16, 4, and 2 is 22. Oh my God, it doesn't get any easier than this. The internet, I'm the only place on the internet that uses this Marashio table. I've been using it for years. The Marashio table, here we'll trademark it, nice. Nice, nice. Okay, so let's do uno más. Let's take something crazy. Let's get silly. There's some silliness. All right, and now we're gonna convert that, by the way, 1, 2, 3, 4, 5, 6, 7, 8, it's a byte. Each one of these are bits. Bits are the same as digits, okay? So we're gonna get that in base 10. Put it up, 1 1 0 0 1 1 1 1, okay? And now we're gonna make a Marashio table underneath it. You have to start with 1. 1, 2, 4, 8, 16, 32, 64, 128. We're going to add all the ones that have a 1 above it. No calculators. You can do this in your head. I believe you can. Oh, I'm bleeding. See, it makes you bleed, I think. All right, here we go. We have 8 and 2, that's 15 over here. This part is 15. Then we have 128 and 64, that's 192. 192 and 15, 7. And then 207. I like it. I like it. 207. That's it. Why don't you try a couple? Why don't you try 2? Here we go. 1011. Base 10. Let's go to base. Oh, whoa. See, if I put base 10 there, we're in trouble. Did I do that up here? I'm just curious. No, I didn't screw up. All right. Base 2 to base 10. Now let's get something silly and crazy. Like 1 1 1 1 1 1. Base 2 to base 10. That is binary conversions, binary to decimal, decimal to binary. We're going to need that to do the other conversions, octal and hex, and you'll see in the next video.